Okay, so welcome. My name is Daniel Roy Greenfeld, and I guess this is my keynote here at KiwiPycon 2011. I came all the way from Los Angeles, and it was my wife, Audrey Roy Greenfeld, came with me. She, as Danny said, she gave a keynote in 2011. Our daughter, if we're going to continue this pattern, when she's 8 years old, she's going to be giving her keynote in 2026. Or is my math off? I'm in front of like several hundred people, so of course I'm going to get my math wrong. But so it's 2027 is when we're scheduled for her to give a keynote. Can we have a confirmation? Okay. Okay, so for my day job, I'm a coder and vice president at a US-based company called BriteCore. We have employees all over the world. Marketing and HR said if I don't post this slide, I'm in trouble, so that's what that's for. I am one of the co-authors of Two Scoops of Django. And just a little side note, it was, I think, 43 degrees Celsius when we took that photo. So, yeah, that was a very hot day. That's just so you know, I know that's 110 degrees Fahrenheit. So it was a very, very warm day. As Danny mentioned, I'm actually a co-maintainer of Cookiecutter. Audrey came up with the idea for it, and it's used by pretty much most of the Fortune 500, and so it's used in a lot of different places. Okay, so let's get into a bit more of the meat of the talk. I love aerospace. I adore it. I love airplanes. So just keep in mind, this is where my examples are going to focus on. So I hope you like aerospace. I had the honor of working for NASA or with NASA from 2005 to 2010, and it was awesome. I learned a lot of neat things besides Python. A lot of people think I'm just a Django guy. That's not really true. I did NumPy and data science before most data scientists were out of elementary school. And anyway, so we was at NASA. We launched a lot of projects, and since I left NASA in April 1st, 2010, yeah, that is April Fool's Day. I've built projects, I've seen them fail, and every project is awesome when you start. You have these wonderful, great plans of what it's going to accomplish and that it's going to be eternal, like Soyuz. Soyuz is the world's most successful manned spacecraft, or probably all spacecraft. It's been around for 51 years. And yes, it has been upgraded. The version that they're flying today is completely different than the one in use today. And while fancier, more sophisticated pieces of technology have come and go, Soyuz is eternal. Unfortunately, when we build projects, we tend not to build them like Soyuz. And a good example is the Cookiecutter. Has anyone here heard this? Okay. So it was the first commercial rocket. It was launched in 1996, and that is 6 years before SpaceX was founded. So SpaceX isn't a new idea. They just got it right. The first launch, after many delays, it didn't go too far. And the company, shut down the project, and they got out of the rocket business. And it's not because the technology was insurmountable. One could say it's because their approach was. And our projects, not many of us get to work on rockets or spaceships. But we still want them to be magnificent. And a lot of the stuff that we do, especially now with the rise of data science and DevOps, the work that we have has at least as great of an impact as rocket ships. So getting it right is becoming a bit more important. So how did they how did Conestoga mess up? Were they idiots? Probably not. They're probably really smart people. They're probably like Giovanni Caproni. And he was an early pioneer of aircraft. His stuff was used by Italy, England, France, the US, maybe New Zealand. His designs were famously beautiful, elegant, and proven. And he was one of the first commercial aviation designers to go to the monoplane. He was like, I want to do monoplanes. But in 1921, this guy who was the Guido van Rossum of his time, that's how people thought of him, he unleashed the Transaero, the CA-60 Transaero. And if it looks silly to us now, I can assure you it looked silly to them back then. It is considered one of the worst airplane designs ever. It is unbelievably complicated. It's a marvel of complexity. And the question is how could Caproni make a mistake of this scale? Where did he go wrong? Okay, so we're still back in history, and I'm going to give you all a coding history lesson, which is, hold on a second. Okay, so this is a lesson that's worthwhile to anyone who's doing code, and you might have already heard this lesson. I'm going to use a personal hero to explain, to explain one of the guiding principles in anything that I do that's technical, and a lot of you do it already. His name was Kelly Johnson, and one of his designs, he had scores of them, was SR-71, and this was launched in the early 60s, and it was the fastest manned jet plane in history. Nothing else has come close for duration, for reliability. It was an unbelievable success for its time. The only reason why it got retired in the face of satellites was budget fighting within the US Pentagon. So it's a marvel of design, amazing, amazing plane. And Kelly Johnson had a phrase that he would use all the time for everything he did, both as a designer of aircraft, he's a fantastic manager, and that was this. Who here has heard "Keep It Simple, Stupid"? Yeah, you know where I'm going with this. "Keep it simple, stupid" is the concept. It's not an insult when it's said. Like when you first hear it, sometimes you take it as an insult because people forget the comma. When he said "keep it simple," he meant break things down to the simplest components and work off of that. And then for stupid, that ties into being simple, right? You don't want complexity because the rules of business or designing aircraft that you have, that's where your complexity is going to come from. And so the simpler you can make it, the easier you can make it to understand, hence the stupid, the better it's going to be. And there's a penalty for not using KISS. That would be Caproni's big mistake, and he recovered from that. He went on to design many other planes. A more contemporary example, which affected Audrey and I as US citizens, is the launch of healthcare.gov, which is part of the Obamacare initiative. And this was I think they put $700 million into an enterprise Java site where all US citizens could register or find where their state's registration was for health insurance, and it just went down from day one. From the moment it launched, we could not access it, and it became a huge political boondoggle and almost shut down Obamacare. And some people came in, they brought in a Tiger team to rescue it, and they did, and eventually they replaced $700 million of enterprise Java, nothing against Java or the engineers doing it, with a static Jekyll HTML site. Okay? And there's 5% of logic, and I think they might have a Ruby or Python script somewhere doing the rest of it. So they made some early design mistakes because they did not keep it simple or stupid. And the thing is when you have early design mistakes, that always generates needless complexity. And this is like my one slide with bullets on it. When you start a project and you don't understand or know the requirements, you can't guess the complexity. You don't know what you're building, which means you are going to make decisions based off of bad data. You just don't know. The end result is you're going to over or under architect. If you over architect, you're going to start complicated. And if you under architect, that means when you get really into the thick of things, you're going to start adding ad hoc organic code that's going to be nasty. Of course, you're going to choose wrong tools because you don't know what you're building to. And you get the devil that is premature optimization. All of this can be summed up as technical debt. And a number of people here are familiar with it because who here has been on a project with lots of technical debt? Yeah, okay. So you've been there, okay. For those of you who haven't, you know, pay attention to this talk. All right, so I'll give you a personal example. Django Packages is a project that Audrey and I started when we were not even yet engaged. It was summer of 2010, about 9 years ago to the day. And it is basically an index of Django packages. It doesn't replace a Python package index. And we started it during a hackathon an online hackathon called Django Dash, where we had 48 hours to release a project. If you've ever used Read the Docs, raise your hand. Okay, Read the Docs, we were coding in the same room for Django packages as Eric Holscher was on Read the Docs. He got 3rd place, we got 10th, 11th? Yeah. And no one remembers who was 1st or 2nd. Anyway, so when we started to build this, we raced and we deployed it, and we got nearly to the end, and we suddenly realized that we hadn't even thought about deployment. This is before a lot of the deployment tricks are out there. Everyone had shell scripts. And so what we ended up doing is actually deploying to a rack-space server, running run server, and our database was SQLite. So that was the story of the launch of Django packages. And it took off. Who here can repeat what I just said? Okay, so we went to PyCon 2011 in the US, and like a lot of people joined us because they saw utility in this, and it was fun to work on. And we just coded, we raced. We were like, oh, they came up with this feature, we'll add this feature. And in the middle of this, I accepted a bad pull request that changed the data, passed the task, but it changed the data structure in a terrible way. And reversing it in the middle of a sprint with, I think there's several thousand people hitting the site, was impossible. And it ended up, it took a really long time to fix. So yeah, this is what you get when you race through and you're not thinking and you're not focusing on keeping it simple. And we fixed it now, but it's a hard project to maintain. Recently, I've lined up some new maintainers, but none of them have uncovered yet our custom Russian doll caching system. And so if they're watching this talk, sorry guys, you'll see what I'm talking about soon. But what we got out of this is some important lessons learned. And at my current job, BriteCore, we operate with, our current product is, what we call in tech a monolith of code. It's got about 1 million lines of code. It's a very sophisticated system, very complex system. We're forced to be complex for a variety of reasons. And what we're trying to do is we're trying to rebuild, we are building the next iteration of it and changing it to something that can account for the needs of the future. For example, going international, where we could support New Zealand as a customer base. And one of the things, of course, is when you build a monolith is you can't have your customers cherry pick features easily. So for example, state insurance in New Zealand might say, well, we only want your claims package. We don't want the rest of it because we have custom laws or regulations in New Zealand. So what we're doing is we're building out individual products, but we're not doing it as microservices. We're not going to build like 2,000 microservices to power this thing. And the reason why is because we've learned over time, I've got years of examples to show you, which is that what's even worse than a monolith is a distributed monolith, where you have 1,000, heck, 50 microservices that can't operate without each other. I know some people might find that controversial, but it is what it is. So when you start a project, let's go over that and how you can plan for the future. And what I mean by Greenfield project is actually, while we're at it. So yeah, I always get the term Greenfield confused with my birth last name of Greenfeld. So it's pretty confusing. I've had this problem ever since I first heard the term Greenfield project. I have to actually think it through. And now my wife, and when my daughter is old enough to understand, she will have the same problems. Sorry, sweetie. Sorry, Uma. OK, so let's go over some of the basics of project design. When we're first laying down by design, I don't mean graphic design. I mean the architecture of a project, how we're going to lay out components, what is our plan. Kelly Johnson, who, in addition to SR-71, he designed the P-38, which is arguably the US's best fighter in World War II. Like I said, I'm an aviation nut. When Kelly Johnson said this, he wasn't calling us stupid. He wasn't calling engineers or coders stupid. He was illuminating that sometimes they're too smart for our own good. And the thing is if Kelly Johnson kept things simple and did, like, just came up with amazing designs, why can't we? And I think the problem is because we often confuse simple with simplistic. When we try to simplify things, we often come from an approach where we're already taking pride in the complexity of what we're doing. And this is a really good example. A number of years ago, I had this pet project of trying to swap 2 position values in a list within a Lambda. And I think at KiwiPycon 2011, someone showed me a version they said was working, but I never tested it, and I lost contact with that person. So if you are that person, I'd love to see what you came up with, because I can't get it where I can really understand it. But anyway, the point is this Lambda is unpleasant to look at, and it's, who knows what edge cases are there. But if we do it instead as a function, it's trivial. It's super easy to understand. I mean, this is my #1 reason why I don't like lambdas in code. It's well, at least in Python. It's just because they often grow in complexity. What starts off as a simple lambda, as soon as you hit that edge case or that special rule, or someone's like, well, I can understand it, that just makes things hard to maintain. And the thing is the foundations of our project should be as simple as possible. Everything that we do should be simple. We want to reduce things down to their simplest element without making them simplistic. And let me go over what simplistic means. This is my favorite example because it's really clear. This is not a bash against non-relational databases, but when you are working with non-relational databases, it becomes really easy to make simplistic decisions about data. Relations are really good if you understand how they work. And there was a time when people thought, oh, we don't need relations in our database, and then everybody learned otherwise. And there are still, I know this, there are still courses and both on commercial platforms and in academia where they actually teach we're not going to teach you relational databases. We're going to teach you non-relational stuff because that's better and faster and it's web scale. I mean, people still say this. So, and nothing against those systems. They're great when they're used appropriately. And the thing is this has even entered in the world of SQL with JSON fields within SQL. Yes, you can search and index on them, but it's not the same as normalized data. And so one of the things I always tell people is if you have a project where you have are tracking relations between components of data, relational databases are really good at it. And the reason why is because relational databases reduce complexity of code. They offload the work that you would have to do building on your project. And I'll give you an example. For example, I'm in the insurance industry. So let's say we're covering properties across all 50 states, and we have to account for the legal differences in. Let's change this. OK. I want to talk about aerospace. So let's talk about planets instead. Imagine my company expands into the solar system, and insurance companies come along for the ride. Okay, so we are insuring properties on colonies or or states or whatever we're going to call them on different moons and planets across the solar system. And we need to track properties in all these different places. And yes, we could dump all the insurance data for one account into a single record. So for example, I could have all my properties attached to my personal record. But then what happens if I have more than one insurance plan for those properties? And what happens if I want to add my wife and she has a different set of properties? All of a sudden, the simplicity of a non-relational system starts to break down. The complexity of maintaining integrity gets really hard. And also, let's say, for example, let's say we just duplicate data. Instead of worrying about relations, all my insurance data is under me, all of it is under Audrey. And then Mars, being Mars, they change one of their laws. And so we have to change the status of insurance accounts across the solar system. At that point, we have maybe 5 trillion accounts. We might be able to figure out how to work it. We can do all kinds of fun things with asynchronous processing, and who knows what we're going to have invented. But we didn't have to if we just used relational databases from the start and understood database normalization. So the way I argue for and against it, at least when I talk to managers, coders often laugh at this one, is if your stuff can work in a spreadsheet, if it models pretty nicely, odds are it's going to work great in a relational database. If a spreadsheet just isn't going to work, like say an organization hierarchy in any real company or organization, you can't model in a spreadsheet. It gets really messy really fast. So that's kind of my rule. The only thing is don't do this. Don't use a spreadsheet to track everybody on a planet. I think Dylan J talked about that at Pycon, Kiwi PyCon 2011. He gave a talk on that. Okay, but the thing is projects do grow to that because people had simplistic thinking. They were using the wrong tool. They thought they could expand things. And then the code got complex. And when the code gets complex, when the foundation of your project gets complex, it gets harder to maintain. And since your business is where your complexity should be coming from, that means you've just squared your complexity, which is basically technical debt. This is where you get into problems of not just debugging, but enhancement, all the nightmare stuff that make us think, do I really want to work on this project anymore because it's not fun? So the thing is when you're dealing with complex code or hierarchies, whenever you have too many if statements, when you have nested ifs, that's one of my trigger signs when I'm looking at just bare code. Another one is if I see functions or methods where I have to scroll for a while. If you look at my personal code, you'll see I always try to keep it, if it can fit on a monitor screen without me having to scroll, that is my ideal. Everyone else has their own personal preference. I'll give you an example of what I mean. The default JSON, wow, I think I misspelled. Did I misspell JSON encoder? No, it just looks funny on the screen. Okay, so the default Python JSON encoder type does not support some really useful types. And our solution, when we realized this years ago, was, hey, the Django version does support it. We're not using Django this is when on projects where we're using Django, but we'll extract it because we know it does, and then we'll release it as an open source package. And the problem is that how do you test this? How do you support this with 100% test coverage and make it look decent? And without having to and if you look at the Django test for it, it's like, wow, this is a lot of heavy lifting just to test whether or not your JSON encoder works. Maybe there's an edge case. So we created what we called the standard JSON encoder, which is ECMA 262 compliant, and there's another standard it's compliant with. And if you notice, there's no nested ifs because we moved the actual functionality to easily tested functions. And this meant that we could spot and remove edge cases, and I think we did. It's been a few years since I looked at it, but I'm pretty sure there was like a subtle thing, and maybe Django has it covered already. Funky Bob, do you know if that's true? Okay. The point is that we can now sleep at night knowing that our JSON encoder was properly tested. We could actually read the test. We could read the individual logic pieces. So the point of this is that we want to focus not on the complexity of the project, but on our project. So don't be an architecture astronaut. Do things right from the beginning. Take your time. And the other thing is, I know I've covered the second item there, but the third one, which is really important, is don't reinvent the wheel. This happens so often, it drives me nuts. To reinvent the wheel, for those of you who don't know, it's a term used in tech to explain when you decide to reinvent something that's already been invented. And for example, creating your own data science framework is hard. It is a huge amount of work. You should use what's out there, PyTorch, TensorFlow, all those tools. There's a lot of money behind them. Odds are you will not be able to, while building your project, build a new data science tool. Another example is the DevOps world. I've seen this several times where, because Kubernetes doesn't do what people want, instead of looking for options out there like OpenShift to fill in the holes, of areas that people feel it has shortcomings, they reinvent the wheel. They do a lot of work that tools like OpenShift provide out of the box. Of course, the example for this is when your project is reinventing wheels. So for example, if you wanted to come up with a system to fill in the holes for Kubernetes, you might have created OpenShift. And this is an Omni wheel. It's really cool. It goes in any direction. They use it in autonomous robots. Pretty neat stuff. When you're rebuilding or reinventing the wheel, when you are doing that, what you want to do is avoid the ivory tower. And this is when you start to build stuff without actually looking at your requirements. Because again, that's where you get complexity in. And this is one that I stumble into about once every year, where I come up with an API design without thinking of the client. And by client, it could be a web front end, a command line tool. And so what invariably happens is I start adding too many parameters. And I think someone gave a talk on she probably explained that better than I did. But if you don't think about your target audience when you're building something, it's going to fail. So it's important when you are building any backend to not just think about the client, because you're going to get it wrong, but to have at least a mock-up to build to. OK, so let's segue into another part of keeping it simple, and that's best practices. And my general rule is you want to insist on them. It's not just because I've written books about it. It's because this is why. Whenever you have inconsistent practices and standards, it means that, for example, Graham Dumpleton, he might look at my code and have to spend time thinking about what did I, what was I thinking when I wrote this? Because my style is so different and distinct. This is why we have things like PEP 8. This makes it easier to debug. You don't have to think about someone's wacky style and way of naming things. And when things are easy to debug, it means features are more fun. And most importantly, especially in a company with 150 engineers like mine, it means that instead of taking people several months to get up to speed, we can get them up in days, which is pretty awesome. So in the Python world, the way to, my opinion, the best places to start are study PEP 8, PEP 20. From there, you can find articles and talks about these, both PEP 8 and PEP 20. And of course, if you're in Django, there's Two Scoops of Django. And we're thinking about doing, instead of another version of that, we're thinking of doing a cheese-based one for Python, because we like cheese. Who here would like to see a Python book on best practices and coding standards? OK. That's a good number. OK. By following best practices and coding standards, we're making our project easier and more fun. And when we're doing that, we're avoiding premature optimization, because we're following a set pattern. Instead of thinking, how can we optimize our code more from the beginning? If we follow best practices, a lot of those discussions about optimization can go away. And I know all the experienced people understand this. For those who are new to Python in this room, understanding best practices is really going to help you, including especially on interviews. OK. Yeah. OK. I'll do a quick aside on that. If you are doing a whiteboard interview, which I'm opposed to, but let's say you're in one, and you're not PEP 8, if you're not following the coding standard of where you're interviewing for, that is a mark against you. So pro tip for interviewing, learn PEP 8. OK, so this is about kissing forever, which is maintenance over time. So when we document, like a lot of you probably heard, oh, you have to document your stuff, you have to document your stuff. This is how you do it. And my rule for documentation is this. I pretend I'm stupid. I pretend like my memory is ephemeral. I have the memory of a mayfly. I'm going to be dead in a few days, and then all my knowledge is lost. So what that means is when I do forget things and try to pick things up back ahead a few months from where I am now, I can. Or better yet, if someone else is following me, they're not yelling and screaming because I didn't document my stuff, even basic usage. The constant example I see of this is undocumented DevOps. So often, like every time I've been on a project where DevOps is like, well, you can just like look at the source code. Every single time, that project has had delays and edge cases in deployments that have killed us. So if you are in DevOps and you can't document at least basic usage, fix that. A test. Everyone here should know to test. A really critical part about testing, though, is your testing needs to work on your projects. If you're I see some people smiling about this. If your stuff isn't running correct builds, and yeah, I know some of my open source projects are there right now, that's your number one priority. Everything else is secondary. Stop what you're doing and fix it. This isn't just for open source. This is for personal projects. If someone says, hey, I know someone, do you think BriteCore might be interested in hiring them? If I find that their projects have failing tests, I'm like, If I'm on the job and we have failing continuous integration, yeah, everything has to be fixed right away. The other thing is testing the hard stuff. When you are testing, it's fun, writing tests is great until you get to about 80%. And then that last 20% is murder. And the reason why is because that's when you're running into the hard to test items. And I'll give you the Cookiecutter example. It started in 2013. Again, almost to the day is when this conversation happened. I didn't want to test input. So Cookiecutter is a command line tool which will build out entire projects for you. It's used by AWS for SAM. It's used by LinkedIn. It's used by Yelp. There's hundreds of companies that use it. I know Ansible uses it. And the great thing about it is it works on all operating systems, even with Unicode. So this is what Audrey said. Uma wasn't in the discussion. She wasn't born yet, but had to get the baby pictures in. I didn't want to test them because I had no idea how to do it. It wasn't readily documented then. It might be now. But Audrey insisted, and this is what I believe was the original code that we got working. And this was instead of going out to hang around Lake Jaroon, but it paid off, and you'll see why in a minute. This is the modern version, which is powered by PyTest. So the proof is in the pudding, because I know GitHub stars aren't important, but we have over 10,000 of them. So yeah, that's me and my ego. And like I said, there's all these companies that are using Cookiecutter, and the reason why is because they know if they build a tool with it, it will work, period. Because we tested the hard stuff. Now, with Cookiecutter and lots of other things, including Aviation, which I'll get into in a second, when you start having those successes, like me claiming, it works everywhere, that's when you get yourself into trouble. And a good example is Giovanni Caproni. Sorry to all my Italian friends. He was amazing as a designer. He could do no wrong, and yet he did. And the thing is when we get successful, this is where we deal with things like overconfidence and complacency. And this isn't just Daniel Roy Greenfeld talking about in a room. This affects people's lives. All of this does. The Boeing 737. Odds are everyone in this room who has been on a plane has flown in a 737. It is the most popular commercial airplane in history by an order of magnitude. It is awesome. It is reliable. It's a great plane. But with that success came complacency. And I don't want to say that the engineers or the managers on it were stupid, or maybe I do. But with the release of the Max, people died. We all, the whole fleet is grounded. Who knows when it's going to take off again? But this isn't the first time stuff like this has happened. This mistakes made on the Challenger, some of them were repeated on the Columbia. And it's because of complacency. We know these things work, or we can't fix this, which is a version of not testing the hard stuff. My point in this talk is that we, as coders, have a responsibility to do good work. People die. And I know I've been bringing up aviation a lot, but there's a lot of other fields affected by Python and programming, pretty much all of them. And in all of these, people can get hurt, governments can change, wars can happen. In my case, we have to pick up after catastrophes. Everything that we touch as engineers can be affected when we don't do a good job, when we're sloppy, when we don't keep KISS in mind. And to summarize this whole talk, Kelly Johnson, he had his failures. And of course, Giovanni Caproni had the gigantic humorous failure. But at the end of the day, most of their career, all their successes could be attributed to keep it simple, stupid. Giovanni Caproni's designs were noted for their elegance. That means simplicity, or that means they were simple. They were well created. So if you're in this room attending, I know you're smart and creative. I know there are topics here that you can talk to me about that will go over my head. And so I know that all of us are capable of doing this, of building really good stuff. Just do it. So yeah, so that's my talk.